Okay, Santa parked his sled 5 meters from the edge of a 20-degree roof. Do you know what is a sled? Yeah, do you know what is a sled? Santa sled? This is the sled. Do you know the sled? The deer is pulling on the sled, where the Santa is riding on it. This is the sled. Yeah. Okay. So Santa parked his sled 5 meters from the edge of the 20-degree roof. So actually, it's good. You already have a picture to help you to understand the situation. Maybe let us straight away transfer the information to the diagram. Okay, then we can understand even clearer. Now, he said this roof is 20 degree. So this is 20 degree. Okay, let us put the information here. So this angle is 20 degree. Right, 20 degree. 5 meters from the edge. So that means from here to here. Yeah, from here to here, it is 5 meters. From here to here, from the roof, from the edge of the roof to the where it parked. This is where he parked the sled. Parked the sled, and then the sled fell down. You understand? 5 meters from the edge. Okay, park 5 meters from the edge. Park the sled 5 meters from the edge. So unfortunately, the parking brake failed. The parking brake failed, then the sled will fall down. Santa sled slide down the roof and landed on the ground 6 meters from the wall of the house. 6 meters is from where? Okay, this sled fall down to the ground. Okay, this is the ground. Okay, it land on the ground. Okay, 6 meters from the wall of the house. So this is the wall. This is the wall. Okay, this is the wall. So how far it land? It land over here. It land on where? He land on the ground. It land 6 meters from the wall. So this 6 meters. This is 6 meters. 6 meters is the horizontal displacement or the range. So Sx is 6 meters. We got one information here. Given that the velocity of the sled after sliding 5 meters is 5.11 meters per second. So that means this sled fell down 5 meters, and then the velocity after sliding 5 meters, velocity after means the velocity at the edge of the roof. Okay. So this 5.11 meters per second is the velocity after the sled travel 5 meters, sliding 5 meters. That means this velocity is velocity at the edge of the roof. Velocity at the edge of the roof. Velocity of the sled at the edge of the roof. Okay, this 5.11. So we can write it over here. This is 5.11 meter per second. That's the initial velocity. Initial velocity for the projectile motion. Yeah, this sled slide down 5 meters. After sliding down 5 meters, it achieved a velocity of 5.11 meter per second at the edge of the roof. So this 5.11 meter per second become the initial velocity for the projectile motion until it landed on the ground 6 meters away from the wall. Understand? So 5.11 is the initial velocity for the projectile motion. So now the question is, how high is the wall of the house? So he want to find this height. The question want to find the height. Okay, so why? So the height is referring to vertical displacement or SY, to find how high about the, this is actually the height. To find the height, normally refer to displacement in Y component. Okay, so This one has two components. You have x component and y component. You need to do separately. First of all, what do? You gather all the information you get here into a table first. Tabulate your data. Tabulate your data. Then tabulate into x and y components separately. Then you can find the according values. Yeah. First of all, you will write acceleration first, because this is the first thing we know about projectile motion. This is a, this one got angle, isn't it? This one got angle 20 degree. So got angle means, and this angle is between 0 to 90 degree. So this is a projectile motion. Projectile motion, it has two components, x and y. Understand? So the first thing we know about projectile motion is the x component is always a constant velocity. This is the first thing we know. The x component is a constant velocity, where y component is a free fall motion. Okay? Now, we know constant velocity has zero acceleration. Ax equal to 0. Free fall motion has acceleration due to gravity. So ay is negative g, where g itself is a positive value, positive 9.81. Okay. Now, all right. Just put over here, yeah, for reference. Now, what else we have? Yeah, initially, yeah, what information we already have? In the diagram, we have the initial velocity. So let's write the initial velocity u. Okay, initial velocity. So initial velocity, we need an angle, because we need to resolve into x and y components. So what is the angle? Normally we refer to the x-axis. This is the x-axis. So what is the angle of velocity, initial velocity, to the x-axis, to the horizontal? Yeah, he said this roof is 20 degree. You see, 20 degree roof. So this angle is correspondent angle to this angle. Okay, so that 20 degree is correspond to here, to this angle. These two are corresponding angle. Yeah, corresponding angle. So this is 20 degree. So this is also 20 degree. So this velocity can resolve into two components, can resolve into x and resolve into y. So you have a ux and also uy. Okay, resolve into two components. So so ux is equal to so now you see, ux is adjacent to the angle theta, adjacent. So adjacent we use cos. Adjacent we use cos. Uy is opposite to the angle. Opposite to the angle we use sine. So uy use sine. Okay. So another thing is ux is going to the right, isn't it? Going to the right, so this one should use positive. Okay, should use positive, but uy is going down. Uy, you see, look carefully. Uy is going down. Going down is negative. Is negative. Remember the direction. Remember the direction. This one. Remember the direction. Yeah, don't forget about the direction. Going to the right, positive. Going to the left, negative. Going up, positive. Going down, negative. So this is for any vector. For example, like displacement, velocity, acceleration. So this velocity is a vector. So for ux is positive because going to the right. For uy is negative because going downward. If you don't put negative, then bye bye. Your answer wrong. Okay. So you must put a negative sign. Okay. So now let's continue. Okay. Ux is going to the right, is positive. positive, and then using cosine. Okay, so let us write the full one. So ux is u positive u cos 20 degree, or we can write it as a positive 5.11 cosine 20. And then how about uy? Uy is going down. Going down is negative. Negative 5.11, and then this one is using sine. Yeah, using sine 20. Using sine 20. Okay, negative 5.11 sine 20. Yeah, sine 20. Okay, done. So remember, the positive and negative sign, very important. If your uy you forget to put negative sign because it's going down, you forget to put negative sign, then sorry, wrong working. Yeah, you won't get the correct answer. Now we already have this. So what more we have? We have the sx, the horizontal displacement. Yeah, just write x here. S. Okay, s is also going to the right. Yeah, it's going to the right, so it's a positive value. Yeah, so this is also a positive value because going to the right. Yeah, at the right hand side of the origin. So we write it as okay, sx. This is the sx is a positive 6 meter. Okay, positive 6 meter. How about sy? Sy. Sy, this is the one we need to find. Sy, sy is below origin. You should have a negative value. Later on, you should get a negative value. But I expect that it will have a negative value. It will have a negative value. Yeah, believe me. Okay, maybe we just put it there first. Maybe it will have a negative value. Is it correct? Is my prediction correct? Okay. Why do I say like that? Because look carefully, because from here going to down over here, so this is the initial point, or we call it the origin. Yeah, the original level. This is the final point. The final is below origin. You see that? It is below origin. Final point is below origin. So when below origin, this sy should get a negative value. It should get a negative value. You should get actually negative h, negative the height. You should get a negative h. You should get a negative value. Okay, because this final point is below origin. When the final is below origin, the displacement is negative. When the final is above origin, then you get a positive displacement. When final is below origin, you get a negative displacement. Okay, so enough for that. This is just my prediction. Now, how to find sy? I need to find sy. Okay, how high, isn't it? How high? This is how high lah? How high? So how to do this? Okay. All right. So we need to find the how high means the word y displacement. Okay. So how to find this? Can we straight away find from y component? Oh, we have a, we have u, we have 2 information. Not enough. We need at least 3 information to get the fourth unknown. You understand? We need 3 information at least. So we cannot start from y component. You cannot start from y component because only has 2 information. We need to have at least 3 information, at least let's say the time, for us to get the fourth unknown, the y displacement. So we cannot start from y component. We need to start from x component because x component, it has 3 information already. You can find the fourth unknown. You understand? So x component already have 3 information. So from these 3 information, we can get the time because time can always link to the y component. So the time, so remember the time x, yeah, is always equal to time y. Okay, this is where we link the relationship between the x and y component. Okay, now let us find out. Yeah, so we cannot begin from y component, we need to begin from x component. So let's begin with x component. Let's do the x component. Now x component use what formula? SUAT. Again, SUAT is SUTAT, which is S equal to UT plus half AT square. But remember the subscript here, you should put subscript SX, UX, AX, like that. Okay, AX 0, cancel off 0. So what do we have here? We have the U, is it? U is 5.11 cosine 20. And then, yeah, we have the displacement 6, 6, positive 6. And the time, we can find the time. Let's find out the time. Let's calculate. Alright, so the answer for time is 1.2495. Make 4 decimal place, so more accurate. Yeah? 1.2495. So, okay, that's correct. So this is the second. We got the time already. And remember, the time for x component is always the same as time for y component. These two motion, constant velocity and free fall motion, they all happen simultaneously, happen at the same time. So the time x is equal to time y. So we transfer the information we get from here to this table. Okay, write it for time x and also time y. And also time y. Now we got the 3 information here in the y component. Now we can find the one unknown, the fourth unknown. Now only we can continue with the y component. Okay, the y component. So what formula can we use? We already got the time. Time what's the time? What does it mean by this time? Yeah, this time is the same as the time for the projectile motion. That means this time is the time for that means the ball, the slate released from the edge of the roof and land on the ground. The time of flight, the time taken is 1.2495. Okay. Okay, so now we want to find the how high is it, which is the y displacement. So we have 3 information here, can find the fourth unknown. S equal to ut plus half at square. Same formula again. Okay, S equal to ut plus half at square. So remember, this is now all y components. Okay, so now let's find out. Remember the velocity need to put negative because it's going downward. Yeah, so it's negative 5.11. You don't put negative, then you get wrong answer later on. Okay, time taken is 1.2495, which we discovered earlier, and plus half. A is negative g. A also have a negative value. Yeah, A also has a negative value. Acceleration. So negative. G is just a positive 9.81. It's a positive value only. Yeah. So 9.81. Okay. This negative comes from A. Yeah, not from G. Okay. So the time taken is 1.2495 square. All right. So what's SY? Let's calculate. Okay, so I got my answer SY equal to, I got a negative value, negative 9.84, negative 9.84 meter. Is it in meter? Yeah, or in SI unit meter. You must check, is it kilometer or meter? Okay, so it is meter. Okay, now the y displacement is negative. What does it mean by negative? Yeah, correct, because I already predicted yeah, because the final point is below origin, so the sy should be negative. The sy should be a negative value. So I got the sy negative. Yeah, because why sy negative? Because we can say the final point is below initial, or below the origin. Initial is the origin. Okay, final is below origin, so that's why I have negative. Okay, so what's the height? The height don't put negative. Yeah, so we can say yeah, we can say like this. Sy is equal to negative 9.84. The question, yeah, sy is also negative h. Sy is also negative h. H itself don't have a negative value. Yeah, height is just height. It's not displacement. Okay, height is just height. So the negative and negative just disappear. So that's why it got 9.84 meter. This is the height of wall. Okay, this is the height of wall. Is it correct? Is my answer correct? Yeah, almost. 9.85 meter. Why he get 9.85? Probably he already round up the value time. Yeah, maybe he put here 1.25. That's why for sy he get 9.85. Okay, but I still feel my answer is more correct because I maintain as many decimal places as possible. So it's become more accurate if I put a lot of decimal place. Okay, I put a lot of decimal place. So I get 9.84. For me, it is very accurate. Okay, it's also near to the answer. Alright, so it's correct. Okay, see you in the next videos.